as well as Professor Vasagam is also there. I request you to make them panelists.
Chengappa, please.
Thank you.
Yeah, maybe you can say a few things. We still are left with 2-3 minutes.
Yeah. Thank you, Cecilia, for accepting our request. And, I think Bangalore section is doing great things. It is, I think, numbering, I think it is in number 3 in IEEE sections with respect to the members. And they have a lot of activities, a lot of dynamism in our volunteers. I'm really proud to be a Bangalore section member. By the way, I don't know whether you remember me or not. We met in IEEE meetings. I am Ramakrishna, past region team director.
Yes, thank you. I remember we met, and thank you for the invitation. It's my honor to be here.
Yeah, I just joined to be a part of your plenary. Thank you.
Yes, thank you.
Thank you, gentlemen. It's a great show, and wish you all the best.
Thank you, sir.
Thank you, sir.
So,
Sir Vasagam.
Vasagam, sir.
Yeah, hello. Am I audible?
Yes, sir.
Good evening, sir. Yes.
Yeah, am I audible?
Yes, sir.
Hello.
Yes,
Yes. So, yeah, yesterday's program I watched fully, and today also I am ready to watch. So I hope that it is really going strong. So I think all the speakers, I think we should thank them. At the same time, we also maintain the tradition that on time you are starting and also completing. Thanks a lot for all the people who are organizing this. So thank you so much. Okay.
Thank you, sir.
Yes, yes.
Start.
Yeah,
Good
at
evening,
6
sir.
o'clock we will start. Good evening, everyone. So welcome to this plenary session. In this session, we are lined up with 3 talks from eminent people. So we will take questions probably only at the end. So maybe 2-3 questions we'll have time, depending on the time we'll take it. While the participants, if they have questions, they can write it in the chat window, which the speakers will try to answer at the end. So with this note, let's welcome the first speaker of the day, Professor Cecilia. She is a full professor and deputy president of the School of Engineering at the University of Bologna, Italy, where she has worked since 1991, and from which she has received a PhD in electronic engineering and computer science. She was the 2019 president of IEEE Computer Society, and she is 2021 IEEE director-elect. She is a member of various committees of IEEE. She has published extensively on design of test, reliability, and resiliency of integrated circuits and systems. She is a IEEE Fellow, IEEE CS Golden Core member, and a member of the IEEE Honorary Society, that's IEEE HKN. She has received 2 Meritorious Service Awards and 6 Certification of Appreciation and the IEEE Spirit of the Computer Society Award from the IEEE Computer Society. We are delighted to have you here, madam. Today, she will speak on safety and reliability challenges for the highly dependable, highly autonomous systems. So over to you, madam.
Thank you very much. It is my great pleasure and honor to be here. And you should be seeing my screen, right? Okay, thank you very much for the kind introduction. And again, it's my great pleasure and honor to participate to IEEE Connect 2021. As we all know, the continuous miniaturization and evolution of microelectronic technology has enabled the continuous miniaturization of electronic devices, and this has enabled the massive presence and diffusion of electronic in basically almost all the things that we manage daily. And these things that contain electronics can be connected to each other in several layers and exchange information and create the well-known IoT, Internet of Things. And these electronic devices connected through the Internet of Things generate a huge amount of data that are generated, processed, and distributed again, so creating huge potentials for AI. And here we have some statistics. So the amount of data exchanged every day in 2019 due to the connected vehicles was 4 terabytes of data every day. The expectation is that by 2025, we will have 463 exabytes of data exchanged every day. And the statistics become even more impressive if you look at the amount of data that is exchanged every minute, every day. And these are the data referred to 2020. And for instance, in 2020, we had, for instance, on WhatsApp, more than 41 million messages sent, shared every minute, and so on. And so all of this creates huge potentials for AI. And we are assisting to a widespread adoption of AI in several application fields to enable highly autonomous systems for transport, manufacturing, health, and elderly care, and so on. And among these applications, the autonomous vehicle market is expected to have a compound annual growth rate of 21% by 2024. And it's interesting to notice that this expected increase was higher than the one predicted before the pandemic emergency. And this is probably due to the fact that during the pandemic, autonomous vehicles have been proven useful to face the pandemic. Here we have the example of autonomous vehicles used in Florida to transport COVID-19 tests from a drive-through testing site to a processing laboratory. And here on the right side, we have the example of autonomous vehicles used in China to deliver food and medical supplies to infected areas. And similarly, there is expectation of a significant increase in the market of autonomous robots for the upcoming years. And in this field, the expectation is to have a compound annual growth rate of over the 20% by 2024. And also for autonomous mobile robots, probably the pandemic changed a little bit the attitude of people towards autonomous robots that have been found useful to replace humans in dangerous environments. Particularly here we have example of autonomous robots used to disinfect infected areas. And on the right side, we have an autonomous robots used to aid hospital personnel and so on. And as we know, the level of autonomy of autonomous vehicles has been formalized from 0 to 5. And a similar classification of the level of autonomy has been conducted also for autonomous robots, whose autonomy can range from level 1 to level 5. At the highest level for both autonomous vehicles and robots, we have the full autonomy. So we don't have the driver into the autonomous vehicle, we don't have the human surveillance of an autonomous robot. And these autonomous vehicles and robots are free to move in the environment, interact with the environment, with humans, and also with other autonomous vehicles and robots. So there is a trend towards increasing more and more the level of autonomy of our autonomous systems, thanks to the, let's say, increasing use of AI. But the problem is that, of course, the higher the level of autonomy of our autonomous systems, the stronger become the requirements in terms of their dependability, where we know that dependability includes reliability, availability, safety, and security. And particularly, as we know, reliability is defined as the ability to guarantee the continuous delivery of the intended, so correct service for a given amount of time. Availability is the ability to provide the intended correct service when it is needed, so we lose the concept of the continuity of the provided correct service. Safety is the ability to guarantee the absence of catastrophic consequences on the environment and users. And security, as we know, is the ability to protect data from unauthorized access, corruption, and misuse. But the issue is that if we want to increase the level of autonomy of our autonomous system, we need to face several challenges, and I would like to focus here on the safety, high safety and reliability challenges that need to be faced to increase the level of autonomy of our autonomous systems to make them dependable. And particularly from the point of view of the reliability, there is a need to guarantee the autonomous system correct operation for a given amount of time depending on the application, despite any possible fault affecting the hardware as well as the software, of course, in the field. And in this presentation, I would like to focus on the hardware. And with respect to safety, we need to guarantee the autonomous system ability to put itself in a safe state in an autonomous way in case of hazardous conditions. Because, and this of course mandates that the hardware demanded to move the system into a safe state is highly reliable, with of course all the issues discussed a minute ago. Why this? Because, for instance, if we think about a level 3 autonomous vehicle, in case of hazardous conditions, an alarm message can be generated and the driver can be required to take control of the vehicle. If we think about a fully autonomous vehicle, so level 5 vehicle, of course the driver is no longer there. And so in case of hazardous condition, it is the system itself that should be able to put itself in a safe state, where we know that the typical safe state is when the system is doing nothing. So if we think about an autonomous vehicle on a highway, in case of hazardous conditions, there should be some hardware demanded to slow down the speed of the vehicle, move the vehicle to an emergency lane, and move the vehicle from there till a parking lot to then stop the car so that the safe state is reached. So of course, all the hardware, as I mentioned, that is demanded to move the system to a safe state should be extremely high, extremely high reliability. And again, so with the problem of possible faults affecting these blocks and so on. So how can we face these challenges, safety and reliability challenges, to enable highly autonomous systems? We know that fault tolerance design is a well-known approach to provide high reliability that we have seen is needed also to make a system safe. For instance, it usually takes the form of adopting error-correcting codes for memory, self-checking circuits and recovery for data paths, and so on. But the problem, as we will see in a few minutes, is that if fault tolerance design has to be adopted to guarantee the safety and reliability levels required for dependable, highly autonomous system, the fault tolerant design should be adopted for all system components performing safety critical functionalities, whether they are within hardware accelerators, high performance microprocessors, and so on, included the redundant hardware that is used to make them fault tolerant. And we will see what it means in details in a few seconds. In addition, as anticipated before, Fault tolerance should be able to account for all possible faults occurring in the field, so possible and affecting the hardware. So possible resistive bridging faults, transient faults, aging phenomena, and so on, where aging phenomena are not properly defined as faults. So that's why I indicated faults within commas. And in addition, all of these should be guaranteed a sustainable cost. So all of this is challenging. Let us see what are the implications and how can this be achieved. So first of all, which are the faults that could affect our system in the field? We mentioned transient faults that are a major concern nowadays for scaled down technologies. We know they can be caused by alpha particle and neutrons. Alpha particles are atoms of helium that lost the electrons. Neutrons may be generated from the collision of galactic cosmic rays and atmosphere atoms, mainly nitrogen and oxygen. When these energetic particles hit the silicon substrate of electronic circuits, we assist to the generation of a spike or glitch of the voltage on a circuit node. And the spike or glitch is what is typically called a transient fault or single event transient. The problem is that if this spike of glitch affects the internal a node within a combinational circuit, for instance, the combinational part of a data path, then if this spike propagates through the inputs of a latching element, and if the latching element samples a wrong datum, so we have the generation of a logic incorrect datum at the output of the sampling element. And this error is called soft error to underline that is due to a transient fault. So we can have errors within our system due to these transient faults. How likely is it that if we have a transient fault affecting a node within a combinational circuit, we originate a soft error? It is still an issue that it is still being evaluated, or let's say under debate. Generally, we agree that it's not very likely, but it may happen. Instead, if the transient fault affects a memory cell or a memory element, and here we have the example of a transient fault affecting the node before the feedback loop of a latch, then it is very likely that we obtain a soft error. So in this case, the situation is very risky because we have incorrect data within our system, so we can attempt at the safety and reliability of our system. More specifically, what happens if soft errors, for instance, affect, let's say, the memory that contains, let's say, the weights specifically of hardware accelerators. So if the soft errors affect memory elements of hardware accelerators that implement deep neural networks, for instance, for image recognition, it has been verified that if the memory elements affected by soft errors are those containing the DNN weights, and particularly are those containing the exponent or sign of the weight that we can consider usually represented according to the IEEE 754 double precision floating point format, it is very likely that you obtain an image misclassification. So the inference of the neural network is erroneous. And we also did this simulation with some simple neural networks, and we found out that the image misclassification may happen also for the 100% of the testing elements. So this is a likely event. And so consequently, of course, we have an attempt at the safety and risk of the whole system. For instance, if this is a DNN used for image recognition on autonomous vehicle or robot, it has been claimed and proven that, for instance, a moving person can be erroneously identified as a bird. So, for instance, the autonomous vehicle will not brake, and of course, we could have disasters. So, soft errors are of concern when they affect memory elements containing specifically the weights of DNN implementing, let's say, AI for image recognition. And also similar problems might occur if soft errors affect, as we all know, the cache of high-performance microprocessors. So also in this case, we can have safety and reliability risks. So what is typically done? So in the case of high-performance microprocessors, and of course it can be done also for the memories used for hardware accelerators, usually we protect the cache of high-performance microprocessors using error-correcting codes. Error-correcting codes mandate the adoption of additional hardware. So as an example, in the figure denoted by A, we have the block structure of the additional hardware required by a single error correction, double error detecting error correcting code, while in the figure denoted by B, we have the additional hardware at the block level required by a double error correcting code. So usually, for instance, cache of high-performance microprocessors are protected, but usually there is the assumption that this additional hardware that is needed to implement ECC is fault-free and is not affected by faults in the field. Why this? Because this additional hardware is significantly lower in terms of area than the cache array, than the whole memory array. And so we can consider negligible the likelihood that it gets affected by fault. The problem is that while this is okay for current system and current autonomy levels of our system, the issue is, can we continue to do this in case of highly autonomous systems? And we did some analysis. Also, this research has been partially supported by a research grant from Intel Corporation. And we analyzed the possible impact of breaching faults that might affect in the field the additional hardware that is used to implement ECC. And what we have found is that these breaching faults may prevent the correction of incorrect words read from the cache while giving an indication of achieved correction. This is very dramatic because we receive an indication that the word has been corrected, while actually the word read from the cache that can be affected by soft errors has not been corrected due to the presence of a breaching fault affecting this additional hardware. Or another likely event is that due to a breaching fault affecting this additional hardware, actually the ECC structure introduced errors in a word read from the cache that was correct, and simultaneously gives indication of no error in the word read from the cache. So we understand that these are, of course, this condition put at risk the safety and the reliability of the memory, and if it is a cache of a microprocessor, of the whole microprocessor operation, or if it is a memory for another accelerator, of the hardware accelerator. And so if you want to really move to a higher level of autonomy, we cannot, we need to guarantee higher level of safety and reliability with respect to what we have today. And so we would need to account for faults possibly affecting this additional hardware that is required by the use of ECC to protect memories. And so one possibility is to change the implementation and the design of this additional hardware, or other solution can be found. We also analyzed the case of faults affecting resistive memories. Resistive memories can be adapted for hardware accelerators to perform in memory computing, and so to improve even more the performance of this evaluation. And typically in resistive memories, even though it has been claimed that faults affecting the selectors of the cells, so each cell in these memories has its own selector, are of concern, there had been no detailed analysis of the possible impact on the reliability of the whole memory, and so of the hardware accelerator. And we did that, and what we found is that a breaching fault affecting a single selector, so a selector of a single cell, affected the datum written to or read from a large number of cells, up to 64 for a 128 per 128 memory array. And that that's a big problem because having in the memory, for instance, 64 erroneous bits is a high number, and such a high number of erroneous bits cannot be corrected at a sustainable cost by traditional error correcting codes. And so in this specific case, while before, let's say the issue was, and the issue that we discussed before is to protect the hardware that is needed to implement ECC. Here we have the case where the ECC might not be able, at a sustainable cost, to guarantee high reliability, and so new solutions should be devised. And in addition to bridging faults and soft errors possibly affecting our hardware in the field, another concern for current scaled down technology is aging of our transistors, and particularly bias temperature instability is recognized as the main aging phenomenon for today's electronics. As we know, BTI slows down, the effect of BTI is to slow down the performance of our circuit. And so it is a concern for timing critical data paths. So what happens is that due to the slowdown of signal transition, the flip-flop at the end of a data path may sample an incorrect data. And so again, we could have a safety and reliability risk because we could have incorrect data within our system. And in addition, we also proven that BTI may increase the likelihood that soft errors are generated due to transient fault. So it make it worse. It could make it worse, the situation and the vulnerability and the reliability risks associated to soft errors. And for instance, considering hardware accelerators, we evaluated the effect of aging on the transistor of their data paths. And we have verified that the data path propagation delay can increase of almost 35% over the considered 5 years of operation. And particularly, we have verified that we have a more significant increase in delay in the first year of operation that can arrive to be more than the 20%. So it is a very significant impact of delay that cannot be compensated by increasing typically the time marginality of our circuit. And so again, we could have the sample of incorrect data, and so the incorrect operation of our hardware accelerator in the field. And similar problems have been found out also for data paths of high performance microprocessors, so that also aging constitute a risk for the safety and reliability of our autonomous systems. And what are the solutions to this? So I would say the more traditional or widespread solution is to add on the data paths proper monitors, aging monitors that are connected to the input of the flip-flop at the output of the data path, and that are able to generate an error message at their output as soon as a delayed transition of the signal at the input of the flip-flop due to aging occurs. So this way, when this alarm message is generated, a recovery approach can be activated so that for instance, the simpler one is to slow down the speed of the clock so that we avoid that erroneous data generated at the output of the flip-flop, at the output of the data path, due to aging affecting the transistors in the data path. But similarly to what we discussed before, the problem is that if we think about the application of this solution for highly autonomous systems that therefore have high requirements in terms of reliability and safety, we need to guarantee that everything is going well. So this aging monitoring and recovery is a successful approach also in case of faults affecting the aging monitoring itself. So one solution could be to make use of monitors that are able to test themselves with respect to possible faults, generate an error message in case they occur, and properly activate a recovery approach to guarantee that the aging monitor can work effectively and that we do not risk to compromise the reliability and safety of the whole system. So to conclude, there is an increasing interest towards enabling dependable, always more and more autonomous systems. This poses big safety and reliability challenges. Fault tolerance is a well-known approach to provide hardware reliability. It could be adopted also to guarantee the safety and reliability levels required for dependable, highly autonomous systems. But in this case, fault-tolerant design should be adopted for all system components performing safety critical functionalities, including the redundant hardware used for their fault tolerance, as we have seen, and should be able also to account for all possible faults occurring in the field at sustainable cost. So all of this is challenging, but several innovative fault tolerance approach are under development and research. So I'm confident that we will be able to address and to win, let's say, these challenges so that we could continue to increase the level of autonomy of our autonomous systems that hopefully will enable a smarter and hopefully better world. And as a conclusive remark, for those of you who are interested in this topic within the IEEE Computer Society, in 2019, we started a community with technical interest in this field in the form of a special technical community in this topic. We also have still a project within the IEEE, within the Digital Reality Initiative. So if you're interested in this topic, I hope you could join us. You can register at this link, and of course it's free registration, and we are looking forward to work together with you on these issues. That's all. Thanks a lot for your attention.
Thank you, Professor, for a wonderful talk. To open the floor for a few questions. The panelists, if they want to ask questions, they can directly ask questions. And if the other attendees, if they have questions, I think they can write it in the chat window. We will read it out for the panelists. So any of the panelists have any questions to Professor Cecilia?
What is the level of autonomy systems which are available currently?
Oh, as far as I know, in vehicles, they are level 3. So, and then it's questionable. So, in the sense that, so there has been, I think, an accident recently with a car with level 3, but then it has been proven that the driver, in fact, should have been in the driving seat. It was not on his choice. And so there has been an accident, unfortunately. But level 3, the driver, as I mentioned before, is expected to take control in case of hazard conditions. So it should be sitting in the driver's seat. This is at least what I read. So there are level 3 is possible, but basically, as we know, there is basically automatic cruise control. There is yes, automatic cruise control, automatic drive. But what is the big difference? What would make the great difference is the presence of the driver and the attention of the driver or not. Similarly, the autonomous robots that I showed in the picture, they were fully autonomous, as far as I know, that helped to face the pandemic, but they were making predefined tracks with no traffic and so on. So within the hospital, they were moving by themselves. The big issue that will be to have autonomous systems that are able to be fully autonomous and to interact in a reliable way with humans and with the other autonomous systems. So, of course, this involves not only reliability and safety challenges that were those that I tried to address, but also ethical, legal issues and so on. So there are lots of issues around this. But from the technological point of view, there is this need to guarantee a really higher level of reliability than we have today. And so also from the standard definition point of view, we started defining some standards within the IEEE Computer Society concerning the description, the language used in the description, and so on for verification and testing of these autonomous systems. So there are really lots of challenging and open issues. So let's say it's a good research topic. Thank you.
So one last question. Can the autonomous vehicle coexist with the normal vehicles? Can we have something like that?
Sorry, can you repeat?
The autonomous vehicle, yeah, the autonomous vehicle coexisting with the normal vehicles with some sort of a retrofitting.
This would be the goal, as far as I know, but this makes the situation very challenging because, for instance, depends where you live. In Italy, non-autonomous vehicles sometimes do not follow the signs and the rules that much, while the issue is that the autonomous vehicle will continuously follow the rules, and so the interaction may be difficult. But the goal would be to, so we don't know whether it will happen. I think that anyway, the full autonomy is really a goal. Even if they, so let's think about autonomous robots that can replace humans in harsh environment. Right now, they need the surveillance of the person. In full autonomy, the big difference is that there will not be humans around. To make surveillance, and that would be very useful, no? So because really there are also in production, in industrial manufacturing, there are several conditions that are risky for humans, very risky, some process and so on. And to be able to rely on robots, I think it would be good to fully rely on autonomous robots. Then whether they could really interact and to which extent they will interact with humans, as I said, is and thanks for the question. It's very good. It's a big issue from also beyond technology, also legal and ethical issues and so on. But that's really a very good point. Thank you.
Thank you.
So how long do you think you need to get full autonomy? So will it take another 10 years? We will see fully autonomous vehicles. Any guesses?
I don't know, honestly. So I'm thinking more again fully autonomous robots in areas where they, so that I think is not too far. So I would say 10 years may be possible, and to some extent we already have. It depends. I mean, what is the expected interaction with the environment and so on. Autonomous vehicles, fully autonomous vehicles, so somehow we have drones, so they go by themselves, so we already have in some case, but the big issue was what we were discussing before is the interaction with humans and in traffic. That I'm not sure if it will ever happen. As probably discussed before, either we decide that we don't drive anymore, or the interaction with humans that again do not always follow the rules may be difficult. But this is the effort, and then I think it's good to try to arrive to that point, in the sense that when it could be useful, again, I see the relevance of this part of this possibility that is replacing humans in dangerous environment. I think that is really a goal, and I'm confident it will happen. Thank you.
Thank you, madam. Any more questions?
Yeah, Cecilia, it's a very good presentation. Thank you. And I think in IEEE, I think 2016 or 17, there was a presentation on ethics in design of autonomous vehicles. If you remember, I don't know whether you recall, whether I've seen that time. And what it says is, you know, comparing humans, and this autonomy, this thing while designing, you know, human judgment is like, you know, suppose some accident is going to happen. You want to save one person, or, you know, save 3 persons in the car or something like that. You know, that sort of judgment is to be taken by human. Is a real-time scenario is different. While in autonomous, no, that ethics part in designing, this is to be taken care what they say, and it is a pretty good presentation that time it was made. Probably that may be going through the research definitely And I saw one, I think Tesla vehicle somewhere in US. I think they were trying to drive without this thing from west to east part. I think, if I remember,
Yes.
they're planning in 2022 or 23. They want to do that.
Yes.
Anyway, it's excellent presentation. Thank you, Bindu.
Thank you. Yes, within the IEEE, there is within the in the standards, there is a big initiative on ethics, as you mentioned, very good. And so really it's a big community joining also law people, psychologists, and so on. And the big issue is that, so replacing human judgment and, you know, consciousness.
It's a big challenge. Yes.
It's so the big issue also in technology, I think, is as I was trying to mention, to face the unexpected, because this safety is really critical. So this issue that in front of unexpected events, to guarantee that, for instance, the car is able to go to a safe place. And the hardware that is demanded to that should be really high reliability. But typically, when they design for the reliability, we always provide reliability with respect to some faults. So the problem is to model and predict what is unexpected. And also there is an issue in neural networks, how they really behave, how they will behave once they trained and so on, if the situation is really unexpected, so far away from the data with which they've been trained and so on. And this is still, I think, an issue that is very, let's say, hot, is very under analysis. Thank you.
Thank you.
Excellent presentation. This is Vasagam. Okay, you know, former chairman back. It is, but I had you know, guided some students for navigate, you know, the blind person, you know, how to help him to move around with the, you know, embedded software, and also the whatever, you know, wearable computing, and also the whatever is the, you know, the new devices which are coming. So that was one of the societally relevant program for the country also, because they have to be made productive. Without what we said, that project, they have to navigate themselves without hurting others or hurting himself. That is a simple goal. But I think it is too difficult for, you know, for them to move into the building, get into the classroom, and also the outside on the road. You know, whether an animal comes across him or another vehicle comes. So how to avoid all these things? So this, I think, is much more complicated than a robot-driven vehicle. So that is what we understood. It was in the, you know, late 90s. I was involved in that kind of guiding the students for that project. So even there are associations, you know, the Blind Association of India. In US also there are societies doing similar things. So, and the same thing with gesture language, you know, because how deaf and dumb, how they can communicate with the automated vehicle. The normal things, you know, voice activated things are there. So I think a lot of things are there. And of course, I am reminded of Star Wars scenario, you know, millions and millions of lines of code. Finally, how do you do the verification and validation? I think that is going to be the biggest challenge. So thank you so much.
Thank you. Yes, you raise very good points. Yes. Also, verification, validation is a big issue. And again, how you can account and validate with respect to the unexpected, I think, is a big issue. So let's see. Thank you.
Thank you.
So that's a time that we have for this talk. We thank Professor Cecilia for the wonderful talk. A virtual memento for you from the IEEE Bangalore section.
Thank you very much. It has been my great pleasure.
Thank you, madam. So the next speaker is Dr. Ghanshyam Singh Gohil. He received his MTech degree in electrical engineering with specialization in power electronics and power systems from the IIT Bombay, and a PhD degree in electrical engineering from the Department of Energy and Technology, Aalborg University, Denmark. He was postdoctoral research with the Freedom Systems Center, North Carolina State University, where his focus was on combined photonic energy storage system and medium voltage power conversion. Before joining ABB Hitachi Power Grids, he worked as an assistant professor of in the Department of Electrical and Computer Engineering with the University of Texas at Dallas. His research interests include power conversion and its applications to power systems. So he's going to talk on next generation high power converters, opportunities, challenges, and applications today. Over to you, Dr. Ghanshyam Singh Gohil.
Thank you for the introduction. Can you please make me the presenter so that I can share my screen? Yeah, thank you. So let me share my screen.
Yeah, it's visible, sir.
Yeah, okay. Thank you for the introduction, and thank you for the opportunity to present this work. Today, the talk or the topic of my talk is next generation high power converters. Now, the talk is arranged in two parts, given the diverse technical background of the attendees. The first part gives a high-level overview of the challenges happening to the energy sector and its impact on the electricity sector. The challenges that arise due to the change in the electricity sector are also highlighted, and role of power converters in overcoming these challenges will be presented. The second half is more intended for audience with some power electronics background, where I'll talk about challenges associated with the next generation wide bandgap semiconductor-based power converters, and also discuss some of our research efforts to overcome those challenges. Before we go there, let me give a brief introduction of the Hitachi ABB Power Grids. HAPG, as we call it, is a joint venture between Hitachi and ABB, which came into effect from 1st July 2020, with a perspective of accelerating transitions towards carbon neutral future. HAPG, which was previously ABB Power Grids, has a long history of innovation and excellence in electrical engineering, with state-of-the-art products ranging from gigawatt-scale HVDC installations to large power transformers to software to controls of grid and so on. HAPG has 4 business units. Grid automation business, basically through this business unit, we support top 250 global electrical utilities that serve around 5 million customers or electricity consumers. For grid integration, the main products are HVDC and FACS, and we have around 15,000 such installations around the world. These are critical assets as far as the electric network is concerned. High voltage business unit has a portfolio up to 1200 kilovolt AC products. 1 in every 4 high voltage switch gear installed in the world come from HAPG. And transformer business unit has complete range of transformer products. I belong to Power Grid Research wing of Hitachi ABB Power Grids that supports all 4 of these businesses. Here on this slide, a brief information about Power Grid Research is given. Power Grid Research is divided into 7 research centers. I work at North American Power Grid Research Center in Raleigh, North Carolina. Most centers have unique expertise in specific domain. The North American Center works mainly on power electronics, microgrid technologies, power grid resilience, cybersecurity, and some activities in data analytics as well. Okay, so on this slide, I saw the trend in the world energy consumption. And from this, graph, it is clear that energy consumption has increased significantly in last 50 years. From the trend in this graph and other forecast, one thing is clear is that world is hungry for electricity or energy, and there is no sign of slowing down in energy uses in coming decades. This is mainly due to the increased energy demand coming from developing countries. If we see the energy uses, oil is a major source of energy today, contributing to 40% of the total energy consumption. If we see the share of final energy consumption in form of electricity, in 1973, it was, let me turn on the pointer. Yeah, in 1973, it was roughly 10%. In last 45 years, the share of energy consumption in form of electricity has doubled to almost 20%. The rising share of electricity came at the expense of oil and coal. Now, to some extent, transportation sector also contributed to the rise of electricity uses, mainly due to the electrification of the rail lines in developing countries. Multiple recent studies and forecast shows that global electricity consumption will be more than double in next 30 years. So that will bring the share of the electricity consumption to 40%. And certain region of the world, especially Europe and US, will go far beyond this level of electrification in next 30 years. To conclude, I mean, future or carbon neutral world is electric, and electricity has a major role to play. In the previous slide, we saw the trends that shows increased share of electricity in energy consumption. That increased demand has to made by increasing electricity generation. On this slide, the changing electricity generation pattern is illustrated. From the trend in this chart, it is clear that world electric power generation is undergoing transformational change. If we see the share of annual electricity generation from oil, it fell from 25% in 1973 to less than 3%. There is some rise in the nuclear power generation. However, in coming decades, the growth may slow down due to the resolve of Japan, Germany, and other major European countries to phase out nuclear generation. Notably, the renewable generation increased from almost nothing to 10%. And basically, there are three trends are catalyzing these changes. Low price of renewable, including PV, wind. Second is the maturity of distributed generation technologies. And third is the recent policy impacting generation, especially in Europe, Japan, and US. Also, major countries have a vision to become carbon neutral in next 3 decades, which will further accelerate this trend. Now, one thing is clear that carbon neutral future is electric. There are 3 building blocks that are stacking up to deliver this carbon neutral electric future. Connecting large volume of wind, solar, hydro, and other renewable sources. Second is electrifying world's transportation, building, cities, and industrial sector. And third one is the hydrogen or green hydrogen or sustainable energy carriers. So where direct electrification is either not efficient or not feasible, one can introduce complementary and sustainable carriers like green hydrogen. So these are the 3 building blocks that will lead to more electrification in the future. Now, if we see these trends in detail, on this slide, I saw the rise of the renewable generation. So the most efficient, cleanest, and cost-effective way to electrify the world is to harness power from wind, PV, and other renewable sources. Advances in technology and cost reduction for renewables and distributed generation are leading to rapid growth, as can be seen from this chart. And this is mainly due to the price reduction in the renewable technology. So utility scale PV plants, the the LCOE or levelized cost has reduced by 85% in last 10 years and became a cheaper alternative to the conventional sources in many parts of the world, including India. Wind generators have experienced similar cost reduction and technology improvement with price reduction or cost reduction up to 66% in last 10 years. This trend has accelerated in past couple of years. In last 2 years alone, there is a more than 10% reduction in the cost of the wind generation. And as a result of these factors, it is estimated that global renewable energy capacity will grow by tenfold in next 30 years. Now, another mega trend is transportation electrification. So in addition to the renewable generation, transportation electrification also plays a very critical role in the future. The transportation has traditionally been heavily reliant on oil. However, as per the estimate with the growing popularity of the electric vehicles, it is estimated that share of electricity in the road transportation sector will be 45% in 2050. In addition to the road sector, rail and shipping sector will also become more reliant on electricity. Electricity, which provides around 40% of the rail energy needs today, it will become almost or more than 90% in 2050. This is mainly due to the electrification of the rail lines in developing countries. The share of electricity in shipping will also rise to 40% in 2050. In addition to the increased penetration of the renewable and rise of transportation electrification, industrial electrification, urbanization, and digitalization will also impact the energy sector. Electrification of the industrial sector has several benefits, and in future we'll see more and more penetration of the electrical technologies in the industrial sector. Another mega trend is urbanization. Continuing population growth and urbanization are projected to add more than 2 billion people in urban population by 2050. Now, this rate of urbanization will put enormous pressure on electricity distribution systems, especially in large cities or in mega cities. As we heard from the previous talk, digitalization is also on rise. Today, data centers account for approximately 200 terawatt hour of energy use in terms of electricity, and that may grow to 8,000 terawatt hours in next 10 years under worst case scenario. And if the efficiency of the power conversion and data center improves, it may reach up to 1,000 terawatt hour under the base case scenario. So in the previous slides, I tried to give the overview about the mega trends that is impacting the energy sector and the electrical sector in particular. So these trends brings a lot of challenges for electricity sector. So now one of the ways to handle large penetration of renewable source and change in load pattern is to have greater interconnection. Microgrid or supergrids with HVDC interconnection integrates renewable sources with different generation pattern, as can be seen from this plot. And therefore, it reduces renewable integration challenges by smoothing the combined output over time. For example, there are 4 different time zones in US, and basically the PV production can be, or wind production and PV production can be combinedly used through this integrated electrical network. So for example, connecting from west to east shifts peak demand and solar production times, while linking north and south will enable balance the varying electricity demand of hot and cold climates. Integration also complements pumped hydro energy storage, which is the cheapest form of energy storage available today, because this pump hydro plants are location dependent facility that cannot be built everywhere. So that's why interconnection plays critical role in integrating those cheap storage. One such example is Denmark. Denmark has a interconnection with Norway. Denmark produces a lot of wind power, and it's relatively cheap. So when Denmark produces excessive wind, it exports it to Norway. Norway stores it in a pumped hydro station, as a hydro capacity. And when the wind is not blowing and Denmark needs power, basically Norway supplies that power to the Denmark. Basically, here in this interconnection example, hydro capacity in Norway is used as a storage, and that's, as I mentioned, that's the cheapest form of storage available today. And we need storage in order to handle the variability in the renewable generation and peak load demands. Now, because of these changes, it's also impacting distribution sector. Now, increased electrification will demand installation and upgradation of distribution network, because as I discussed previously, the demand will grow by 20%. So that will put enormous pressure on this distribution network. And challenges includes voltage regulation of the distribution feeder, also the power quality. However, power electronics, most of the renewables are inverter-based resources. So power electronics plays a critical role in solving those challenges through proper control. Resiliency of the future electric network is another performance parameter. And again, distributed generation, storage, these technologies are inverter-based, so power electronics has a critical role in ensuring resiliency as well. Microgrid is another emerging application which can also improve resiliency significantly. So basically, by resiliency, what I mean is like distribution systems should be able to operate if there is a fault in other part of the network and still supply the critical loads within that microgrid setup. Now, because of this changes happening at the distribution level, we'll need capacity expansion, and the role of DC is rising because of this factors. So, for example, renewable energy sources like wind and PV are either DC or variable frequency AC. Also, we are integrating more and more storage in the distribution system. So the battery energy storage systems are also on rise. Use of EV is also increasing, so we need charging stations for EV. So all of these loads are inherently DC, or it uses some sort of DC intermediate stage. So in all these cases, multiple power conversion stages with intermediate DC bus are required as per today's technology with AC distribution system. Now, the rise of this component in the grid present a strong case for the DC grid. So in future, we'll see more DC systems in the distribution as well. Now, because of this changing, there are a few emerging applications. For example, as I mentioned previously, most of the renewable sources are either DC or variable frequency AC. And MVDC or medium voltage DC can be used to collect power from these renewable sources. For example, for the offshore wind, MVDC collection grid can be used to improve the power collection efficiency and cost of the installation. Also, with MVDC technology, the space requirement inside the wind turbine can be reduced. As a result, it can be made more lighter and installation cost can be reduced. This is critical for offshore installations. In utility scale PV farms, we are seeing 1.5 kilovolt solar panels. In future, due to advancement in the module technology, we'll see up to 3.5 kilovolt DC panels. That will also give rise to the medium voltage power conversion technologies or MVDC. Also, there are other application cases. For example, most of the medium-sized distributed generation plants are typically connected directly to the sub-transmission level or a substation on the MV side. Now, in order to avoid expansion of the sub-transmission network, MVDC could be used to connect this new distributed generation plant to the existing stations located further away. So the congestion management is another application case for the MVDC. Also, MVDC present a strong case for integration of large DC loads such as data centers and fast EV chargers. And it can reduce conversion losses and power quality issues. Also, another mega trend is mega cities or urbanization. And in mega cities also will need a DC distribution in the future. So this is like a simplistic representation of the electric power system of the future, where we'll see increased use of HVDC and MVDC technologies for dense cities as well. Now, in all this emerging application, we need medium voltage converters. So if you see the traditional power converters used in power system, those are mainly for high voltage DC transmission. But now with these changes happening in the electricity sector, we'll see more and more applications of the medium voltage power conversion technologies. So now for both HVDC and MVDC applications, we'll see uses of modular topology. So this is one example of the modular topology, where submodules are connected in series to match the voltage rating. And this is a typical schematic of the full bridge submodule. Now, in future, we would like to reduce the cost of this technology so that it can be, we can increase the penetration in the electricity sector. The major cost contributors are semiconductor devices, the submodule capacitor cooling systems. The cooling system cost can be reduced by improving efficiency. Now, in modular topologies, it's the conduction loss that dominates. So by reducing conduction losses, we can improve efficiency, reduce the cost of the cooling system. Now, in order to achieve that, in future, we'll leverage wide bandgap semiconductor devices. So in this figure, we have a Baligas figure of merit. The key takeaway from this figure is that by using wide bandgap semiconductor, the on-state resistance can be reduced by more than 100 times compared to today's technology. Also, as I mentioned, submodule capacitor is another cost contributor. The cost of this capacitor can be reduced by increasing the voltage rating of the submodule, since the energy stored in the capacitor is proportional to the voltage square. Increase in voltage will reduce the capacitance for the same energy requirement. Again, wide bandgap will play a critical role. So this is the example of 10,000 volt MOSFET, which can be used for this application. However, these modules or these MOSFETs are still in the early stages of the development. So another alternative is to use series connection of the low voltage MOSFETs, 1200 volt and 1700 volt silicon carbide MOSFETs. The cost of these MOSFETs are decreasing due to the penetration in EV and photovoltaic sector. So this is another viable alternative to realizing high voltage submodules. Now, here I'll talk about our research work in building such module using 10,000 volt MOSFET. The fast switching speed and high voltage operation of this 10,000 volt MOSFETs bring a host of new challenges, especially for the gate driving and auxiliaries. So in this work, basically we developed the submodule with a special focus on the gate driver. Even in the gate driver, the power transmission is challenging because now there are several performance parameters that needs to be considered while designing this power transfer for the gate driver units. One of the major challenge is the conducted EMI. So basically this power transfer is happening through isolation barrier, which has a coupling capacitance. Now, if you see the gate driver that is driving the 10,000 volt MOSFET, it has a very high dV by dt, rate of change of the voltage. It could exceed 100 kilovolt per microsecond. And if the coupling capacitance is high, which is the case with the traditional power supplies, we'll see a very high common mode current flowing from power circuit to the control circuit. That could lead to the ground bounce issues, may lead to the false operation of the digital circuits on the control side. So that's why it's critical to reduce the conducted EMI by reducing the coupling capacitance of this power transfer unit. Another challenge is the high isolation requirement or high voltage withstanding capability requirement. Now here we can see that here in this table, the clearance distance are mentioned depending upon the voltage class. Here the creepage distances are mentioned. One key takeaway from this table is that we require very large distances to achieve these requirements or to meet these requirements with the conventional technology. So we need different technology to meet this requirement while achieving a smaller footprint. So in this work, basically that's what we did. We came up with a different approach for powering this gate driver. Our idea is to use wireless power transfer for powering up the gate driver while achieving smaller footprint and small coupling capacitance simultaneously. Here, this is the example of the conventional wireless power transfer approach reported in the literature. So if you see the from this diagram, if you see the electric field or the electric flux is the surface integral of dot product of electric field and area. Now, in our approach, we try to reduce this electric flux by reducing the surface area by using smaller coils. So this is like pretty large coil. In our approach, we use smaller coils. Increase the angle between electric field and the surface. So using this kind of approach, thereby reducing the electric flux and the parasitic capacitance, and increase the distance between the coils. I mean, that is the last resort in our approach, because that also leads to the size increase and coupling efficiency reduction, magnetic coupling efficiency reduction. This is our approach. So here, if you see the conventional approach, it has two parallel coils overlapping each other. In our approach, we have coils, but they are not overlapping each other, smaller in size. Here, this is the realized prototype, and you can see the power supply for the gate driver is almost hidden. Here, the transmitter and receiver coils are embedded in separate PCB. So here you see transmitter coil on a separate PCB. Receiver coil is inside this box. It is ported in epoxy to achieve a required clearance or to avoid or to achieve smaller footprint. Let me put it that way. Now, this is gate driver is of course one thing. In addition to that, you require multiple other research efforts to build these power modules, but I'm highlighting the gate driver unit here. Now, here I give the comparison between conventional approach and our approach. So if we build the wireless power transfer system for the gate drivers using conventional approach with two overlapping coils, the parasitic capacitance could be 18 picofarad, whereas in our approach it is 2.2 picofarad. So significant reduction, almost 8 times reduction in the parasitic capacitance, meaning 8 times reduction in the common mode current or conducted EMI to the control circuits. In addition to this, we use also ground shield and use it to further divert the common mode current. Here on this slide, I show the distribution of the electric field In this case, it is less than, or it is just over 1 kilovolt per mm, which is significantly lower than dielectric strength of the epoxy that we use, which was around 25 kilovolt per mm. So this can withstand high voltages, reduce small capacitance. That's the main highlight of this slide. These are the results. Basically, you can see the measured common mode current or peak value of the common mode current. This result is without that ground shield that I mentioned previously. With ground shield, peak value is reduced to 130 milliampere. So as I mentioned, with the conventional approach, this is 8-time reduction in the conducted EMI, meaning now the control logic and other low voltage circuits can operate more reliably. Now using these submodules, basically we also build a converter for the EV charging application. So this is a schematic for fast EV charging. Now range anxiety in EVs is a major concern or a major obstacle for increased adoption of EVs. Now in order to overcome that range anxiety, we need charging infrastructure that can reduce the charging time to the typical refueling time of the IC engines. So extreme fast charging is one of the approach to achieve that. Basically with extreme fast charging of let's say 350 kilowatt, 200 miles of charge can be delivered in less than 10 minutes. So along with the efficiency and compact, so there are two major requirements for these charging stations. Efficiency is one, and compactness is another criteria, especially for the dense cities. Now, a major obstacle in achieving small footprint is the line frequency transformer used in state-of-the-art chargers. So in this work, basically we avoid use of the line frequency transformer. We use medium voltage power converters for direct medium voltage interconnection. So here is the architecture that we propose for this extreme fast charger. Medium voltage device-based front-end converter followed by isolated DC to DC converters. Now here we have 400 volt EVs and 800 volt EVs in the market. So the charger needs to meet those or should be able to deliver power in large voltage range as far as the output is concerned. The resonant converter used in DC to DC converters, basically they are not very efficient if we increase the range of the output voltage. So that's why we propose reconfiguration, parallel DC to DC converters and variable intermediate DC bus operation to make these converters more efficient. The next thing is the design optimization of this converter. Now, typically in the design optimization of the power converter, it is observed that typical performance parameters, which include efficiency, size, cost are normally coupled. And if we use single objective optimization, that would often lead to poor performance regarding other performance parameters. For example, if we try to improve the efficiency, the cost will increase or the size will increase. So the strong coupling exists in the design. Now this effect can be compared with the whack-a-mole game. Now in this game, you sink a mole by hitting it with a mallet, and as soon as you do that, mole from another hole will pop up. Design is a similar problem. Therefore, in this work, we do the multi-objective optimization, where the objective was to minimize the volume and energy loss for a given charging profile. In our design for the fast chargers, we consider around 30 design parameters that include switching frequency of the front end and DC to DC converter, magnetic component design parameters, filter parameters, and so on. Here, I give the Pareto front. So as I mentioned, this is a multi-objective optimization, which leads to the Pareto front. So these are all optimal designs for the front end. These are all optimal designs for the DC to DC converters. and then we select one manually out of this feasible design in our work. Based on that design, we build a power converter. So this is a medium voltage power converter stage. This is a low voltage power converter stage. The medium frequency transformer and the prototype testing facility here. The key findings are that with this approach, the power density can be reduced to 3.2 kilowatt per liter. The front-end converter volume, including filter and everything, is around 72 liters. DC to DC converter volume is around 37 liters, and full load efficiency was around 98.6%. Now, if we compare it with the conventional solution, which uses line frequency transformer and low power electronics, the data is not available, but if we just compare the line frequency transformer, 350 kVA unit will have a volume of around 1400 liters. So transformer power density alone is around 0.25 kilowatt per liters, meaning with this technology, we can make this fast charger 13 times smaller in volume. Also, the transformer efficiency is in this range, 98.4. For this particular example, power converter will have a efficiency also in the same range. So if we take the combined efficiency, the medium voltage power conversion approach can bring 2 times loss reduction. So in summary, basically there are a lot of changes happening in the energy sector that includes increased penetration of the renewable, transportation electrification, urbanization, digitalization, electrification of the industrial sector, and that is impacting the electrical sector in a big way. So basically, we'll need expansion of transmission and distribution network due to the rise demand in electricity uses. Traditional generators are being replaced by highly variable and seasonal generation, increased peak power demand due to the EV chargers and simultaneous charging of EVs in the same locality, reduced inertia due to the replacement of large generators, rotating generators that leads to frequency stability issues, voltage limit violations. In future, we'll see today's distribution network is radial. In future, we'll see mesh network, and these challenges can be handled by, or this challenge leads to many emerging applications like super grid or microgrid, as I discussed, microgrids, power flow controllers, solid state transformers, and MVDC applications. In all these applications, medium voltage power conversion will play a critical role. So a lot of changes happening in the electricity sector, and this is a very exciting time to be in this field. So that's all I have. Thank you, and I
Thank you, sir. So we have time for 2 minutes for probably one question. Anybody from the panelists who want to ask a question?
Is ABB working on digital twins?
Yes, I mean, digital twins are becoming popular in many sectors, including electricity. So yes, I mean, we are working on digital twins, and there are multiple application cases for the users of digital twins.
Especially in the power system applications.
Yes, yes. I mean, we are a equipment manufacturer. So basically, predictive maintenance is one of the application case. So reducing maintenance cost is like the priority. So that's why digital twins are gaining a lot of attention for the predictive maintenance. And there are other application cases like for the microgrid control, for the distribution automation, and so on.
Okay.
I think that's all we have time for the session. So let's thank Dr. Ghanshyam Das for a wonderful talk. It was very exciting to know what's happening in the electricity sector. Thank you again. As a token of appreciation from the Bangalore session, we present to you a virtual memento.
Thank you.
Thank you, sir. So we will move on to the next talk. The next speaker is Professor S.K. Ramesh. Professor S.K. Ramesh is a renowned engineering educator with over 3 decades of leadership experience as a dean, departmental chair, and a faculty member in the California State University system. He is presently a professor of electrical and computer engineering at California State University and founding director of CSU Nottingham's internationally recognized AIMS2 program that mentors and supports underrepresented minorities in engineering. Professor Ramesh has an active IEEE volunteer for 39 years and has served in several leadership roles across IEEE. He is in 2021-22 is a president-elect of ABET, the global accreditation body for programs in engineering technology, computing and applied and natural sciences. As 2016-17 Vice President of IEEE Educational Activities, he championed innovative programs like the IEEE Learning Network that has grown to include over 1,000 courses and webinars from 30 societies and IEEE OUs. Professor Ramesh is an IEEE Fellow recognized for his contribution to opportunities in engineering education, contribution to entrepreneurship in engineering education, and a member of Photonics and Education Society. His research interests cover high-speed optical communication systems, devices, and electronic system design. So today he's going to talk on engineering the future in the post-COVID era. Over to you, Professor S.K. Ramesh.
A very warm good evening to all of you in the Bangalore section. Section Chair, Dr. Bindu Madhava, Professor Muralidhara, Dr. Kumar, my distinguished fellow panelists. It is really a great honor and privilege to be with all of you today to share some thoughts about engineering the future in the post-COVID era. Because trust me, COVID will be behind us and we will be looking forward to a bright future ahead. Now, having said that, let me first begin by hoping that all of you and your loved ones are safe and healthy. And let us pray for those that are facing challenges and hope that they recover very soon. I'm going to begin sharing my slides momentarily, and I have a few video clips as part of my presentation, and let us hope that they will work. But if not, as we say in IEEE, advancing technology for humanity, we can't let a small matter of technology get in the way, can we? So here we go. So let's see. Bear with me for a second as I find my presentation here. I hope you're able to see my screen at this point, everybody. Wonderful. Let me put that up in presentation mode and we should be set to go. Wonderful. Thank you again. So I entitled my remarks today, Engineering the Future in the Post-COVID Era. And the picture that I wanted to show you for inspiration really doesn't need any introduction. It is our late President, Dr. APJ Abdul Kalam, whom I was privileged to meet over a decade ago. And I'll tell you why I'm starting with this picture, because if the past is a prelude to the future, certainly my journey in the IEEE started 40 years ago. That's me, believe it or not, at my alma mater, which was then REC Trichy. Now it's called NIT Trichy. I was one of the founding members of the IEEE student branch back in 1978. In the ECE department, among the very many things that we did, we actually had a electronic newsletter. I say electronic because we thought that was electronics back then. We typed it, we printed it, We distributed it to all of the students in the department, appropriately called bandwidth. And when I look at where I've come today in my journey in the IEEE, I really believe that everything that I've accomplished technically, professionally, is thanks to IEEE. So I owe a big debt of gratitude to my colleagues, to my teachers, to my classmates, to all of the people that have helped me along this way. Today, as you heard from my introduction, thank you, Dr. Murdadara, for that gracious introduction. I serve as a faculty member in the California State University system, which is the largest public university system in the United States, serving over 500,000 students with about 50,000 faculty. Like many of you, our system went virtual, probably about 15 months ago, back in March of 2020. So what are we going to talk about today, and how is this so relevant to where we are? So I was telling you about my conversation with President Kalam, and if you haven't read his book, I would recommend that you pick up a copy. It's called India 2020, A Vision for the New Millennium, authored by Dr. Kalam. And when I talked to him, and here's an excerpt from the book, he talks about the 4 important areas of development, namely people, economy, strategic strength, and infrastructure. But more importantly, take a look at what he says about how we can achieve these areas of development. He says that technology is the answer, not just unmitigated expansion of technology, but technology that is not only for the classes, but for the masses. So we need to minimize waste, we need to minimize environmental pollution, and we need to be able to support everybody in society. Now more than ever, that seems to be very relevant to the situation that we face. And then, invoking the words of another late president, Pranab Mukherjee, here's something that he said on the occasion of the birth anniversary of Acharya Satish Chandra Mukherjee, who was a teacher and educationist of the early 20th century. And pay close attention to his words. He said, if we can make the necessary effort by creating teams of inspired teachers, by establishing linkages with the global educational fraternity through the maximum use of information technology, by placing emphasis on research, results will follow. Ladies and gentlemen, here we are today, engineering the future in a post-COVID era. So here's what I want to share with you today. I first want to talk to you briefly about the changing landscape, how things have changed dramatically in the last 15 years. Then speak a little bit about innovation and the grand challenges that confront us. At that point in the presentation, I want to pivot to IEEE's role, because you see, IEEE has an integral part to play in engineering the future and protecting our profession. And many of you, members, volunteers around the world in the Bangalore section, all across India, are wondering what kind of resources are available from IEEE. IEEE has an ocean of resources. So I'll touch upon a few of those, give you a few examples from my experience in the area of educational activities, humanitarian activities, and the last piece that I want to bring it together is called putting it all together. And here I'll share some practical examples from my experience in the California State University system, one in the area of renewable energy and another one in the area of assistive technology, both of which I see as very important practices for engineering the future. So with that said, if you were attending a Region 10 meeting, this actually happens to be a Region 6 meeting in January of 2020, this is probably a situation that greeted you. We all gathered together, we talked about the challenges facing IEEE, how could we serve our members and so forth. And very quickly, in the space of about 3 months between January and March of 2020, we had students on campuses like this, gathering with their laptops, engaged in lesson plans, going from a face-to-face modality to something like this. No, I'm not suggesting that their faces changed into computer screens, but you get the picture. We went very quickly from face-to-face interaction to a completely virtual type of modality. And that was necessary because of the challenges confronting us, particularly with COVID-19. So it is important here for us to remember the words of the National Academy of Engineering from the United States. This is a publication that they came out with in 2008. And I want to share this excerpt with you because I think it really sets the stage of the role of engineering. And here's what they said. They said, no profession unleashes the spirit of innovation like engineering. And please take note of the words that I've highlighted here. From research to real-world applications, engineers are constantly discovering how to improve our lives. And how do they do that? By creating bold new solutions that connect science to life in unexpected, forward-thinking ways. The next sentence, ladies and gentlemen, is so important. Few professions turn so many ideas into so many realities, and few have such a direct and positive impact on people's everyday lives. We are counting on engineers and their imaginations to help us meet the needs of the 21st century. If you're interested in reading this book, you can actually download the PDF from the National Academy of Engineering. But please remember these words in the context of what I'm about to share with you about engineering the future. Few professions have such a direct and positive impact on people's everyday lives. And we're counting on us, namely you, the members of the IEEE, and your imaginations to help us meet the needs of the 21st century. So where are we now? So some of the publications that I've shared with you here are out in the popular literature, the books by Tom Friedman, where he talked about the world is flat, hot, flat, and crowded, where he talks about environmental responsibilities, and two publications also from the National Academy of Engineering, namely The Engineer of 2020, which talks about educating the future engineers. These books came out about a decade ago. When I think about the situation we're in today, somebody asked me the other day, one of my students, we're facing all of these challenges, and yet somehow we're able to manage, we're able to accommodate, we're able to move forward. How do you do that? And one word comes to mind, and that word is resilience. And if you look up resilience, you'll see a lot of different definitions about resilience. To me, one definition is innovating through adversity. Because if you think about Charles Dickens in A Tale of Two Cities, it was the best of times, it was the worst of times, right? But we've moved from those worst of times to a future where innovation is going to be a key to solve the problems that confront us today. Very good. So what are those grand challenges that confront us? Let me start with one first, because the previous speaker was talking to you about renewables and how important renewable energy is to our envisioned future. So if you think about where we begin to engineer the future, clearly lockdowns and working from home had to be instituted because initially we had no idea how we were going to control this virus. So we had to do testing, tracing, and control. We had to use a lot of technologies essentially developed by IEEE members around the world in order to slow down the spread of the virus. And then in the space of about a year, we figured out a way to conduct our business through virtual meetings, through hybrid meetings right now. Meanwhile, we're very fortunate, if you think about the history of the human race, how quickly we've been able to develop vaccines to address the scourge that confronts us. At the same time, we're finding out, and this is true in India, it is true in the United States, a vaccination doesn't provide you 100% protection against the challenges that we face. There are new strains, the Delta variant, the Gamma variant, and so forth. The bottom line is, as a result of this challenge, this unprecedented global challenge, we've had a large economic impact. Whole industry sectors, travel, retail, services, businesses have all been changed as a result of this. So remember again, the definition of resilience. Resilience is not about thinking about what might have been and how can we get back to the past. Back is not the way to the future, but resilience is innovating through adversity. That, ladies and gentlemen, asks us two important questions. How do we rebuild and what do we rebuild? These are important questions because if we can answer these, then we have the opportunity to rebuild what we truly need. Because this is an opportunity. Every cloud comes with a silver lining, and this is truly an opportunity for all of us through conferences like Connect to talk about how innovation is going to be the key going forward to the future. So let me talk to you about some of the challenges. And in particular, I'll pick up on climate change. If you look at the level of carbon dioxide in parts per million, for a number of millennia, the level of CO2 was below this line, below 300 parts per million. That was the 1950 level. Today, if you look at it, it is well over 400 parts per million, well over that. Now, why is that? You think about pollution, you think about greenhouse gases, climate change, severe storms, thunderstorms, extreme weather. We have floods in one part of the world. We have, other parts of the world, there is absolutely no rain at all. We have exploding human consumption, which is gradually destroying the biodiversity that we've taken for granted. And we have the influence of plastics, containers, and so forth. Now, the consequences of this expansion, if you will, in CO2 can also be seen in the actions that we're taking. For example, the safe management of wastewater, the Paris Agreement, which has now been ratified by over 189 parties. And I'm very glad that the United States is now back into the Paris Agreement. 28 multinational companies from around the world, all with a commitment to reach net zero emissions no later than 2050. Technology, again, has a very important role in protecting biodiversity. And we are gradually, slowly but surely, eliminating our dependence on plastic. Clean, renewable energy is going to be in our sustainable future. So having said that, here's an important statistic. If you look at the United Nations, you'll find 139 countries around the world have committed to transitioning to 100% wind, water, and solar for all purposes, whether it's electricity, transportation, heating, cooling, and industry. Imagine the impact that could have on greenhouse gases. Imagine the impact that can have on climate change. Imagine the impact that can have on the future of the human race. Very, very important, right? And then, how do we deploy these impacts? Here, I think the role of IEEE becomes very critical, because as you think about technological advancement, artificial intelligence, robotics, connected devices, future networks, biotechnology, big data, health informatics, all of these technologies are not only going to be important for us from a sustainable standpoint, but are also going to be important and are keys to our envisioned future. So when you think about engineering the future, it is not some artificial thing that we're thinking about that may never happen, but we're really thinking about something that is going to happen immediately in the next 3, 5, 10 years as we collectively work together to make a difference. So we've talked about the challenges, and we also know in the past we've had unemployment because there are jobs lost to automation. But look on the bright side. Look at sustainable technologies. Look at clean energy. Look at the opportunities with transportation. I live in Los Angeles, and on a given day, getting from point A to point B is not a matter of distance, but it's a matter of time. So it could be 20 miles for me to get from CSUN to UCLA, but it could take me 2 hours with the traffic that I have. And oddly enough, during the lockdowns, traffic just completely dissipated, and we started to see blue skies. We started to see birds in the skies. We started to see a lot of change. Biodiversity started to reappear. Smart cities, smart grid, the digital technologies that we are creating. And I'll add one word of caution here. It is not important just to create the technologies. We also need to provide access, because without access, we can never get to the point of a sustainable future, right? So what is IEEE's role in all of this? So you've heard about the challenges. You've heard about engineering the future. What's IEEE's role, right? So when you think about IEEE, we think about our membership. We think about the number of countries that we're in. We think about all the technical societies, over 125,000 student members. Our annual conferences, almost 2,000 of them. We produce about 5 million technical documents. 23 of the top 25 journals in the field of electrical engineering are in the field house of IEEE. We have active standards in everything from wireless to communications to power to electronics to health informatics. But perhaps the most important thing that I think about the IEEE is our social impact. The impact of IEEE on global humanitarian efforts, the impact of IEEE on global public policy, and finally, very important, the impact of IEEE on ethics and technology. And we're trying to do all of this, ladies and gentlemen, by focusing on education, not just education for high school students, not just education for university students, but education across the gamut, across the spectrum, so that every child, no matter where he or she lives, regardless of culture, has access to education, has access to the envisioned future that we care about. So if you look at IEEE's strategic plan, I'm sure all of you are familiar with this. We foster technological innovation excellence for the benefit of humanity. We'll be essential to the global technical community. We'll be universally recognized for our contributions. Wonderful, wonderful goals. And I've highlighted a few things on the mission and goals of IEEE, which I believe are very critical to our future. But before I get there, take a look at the core values on the left: trust, service to humanity, integrity, partnership, global community building. Think about how quickly we came up with a vaccine to address COVID-19. That could not have happened without the global community coming together through collaboration. And then IEEE plays a tremendous role because, number one, we enhance the public understanding of engineering. We're a trusted source because people look to the IEEE for quality, to provide lifelong learning, as well as career and professional development. And most importantly, through our technical societies, we're inspiring a worldwide audience to build nimble and agile communities, advancing technical interest, informing public policy through conferences like Connect, making a difference, advancing technology for humanity. So what are some of the resources that are available from the IEEE, right? So when I think about resources, and you've probably been to the IEEE webpage, but I'll leave the static link up there just so that you can check it out if you haven't already. So very quickly, when we pivoted to virtual modalities, IEEE did the same thing. And we said, how can we support our members? So we started using technology for virtual events, and we looked at our publications, we looked at our conferences, we looked at our seminars, and said, how can we offer this to our members around the world? So free resources for our members in our particular sections. So if you happen to be in a large section like Bangalore, where you have almost 5,000 members, full members, and you have many more students, how do you address the needs of these members when they're in a mode where they cannot really interact face-to-face? What is IEEE doing to help our members around the world? So one of the things that you'll find under free resources, and I really appreciate the IEEE for doing this, is that it's not just looking at a big feast of resources, but it's looking at it from the perspective of the end user. So if you're a parent, if you're a researcher, if you're a student, if you're an educator, if you're a practicing engineer, you can click on all of these boxes one at a time, or if you're lazy like me, you can just click on all, and it'll show you all the resources that the IEEE has available to you. Let's take a quick preview of those. Look at continuing education, IEEE Learning Network, and I'll have a few remarks to say about this momentarily. Free ebooks, free resources for homeschooling. See, it's not just about technical education. Many of our IEEE members have children at home who are going to school. All of that transition to virtual modalities. What kind of resources can the IEEE provide to help these children from kindergarten all the way to 12th grade and beyond, right? IEEE Learning Network, and this is something that I'll describe to you. I'm very proud of this because it's something I started when I was Vice President for Educational Activities, and it's wonderful to see how in the last 5 years that idea of collaboration, communication, building agile communities with our technical societies has made IEEE Learning Network what it is today. Free ebooks. Yes, I'm old-fashioned. If you come to my home and you look at my bookshelf, I didn't have enough room inside the home, so I actually built shelves in my garage to store all of my books because I still like picking up a book and reading it. So IEEE has a number of ebooks, and last count when I checked, over 373 of them. So even if you downloaded all of them and read one book a day, you'd still have 8 books left at the end of the year to read. So take advantage of these resources. The other thing that IEEE did is out of our 5 million technical documents, we looked at all the documents related to COVID-related research, whether it's people looking at testing, tracing, control, anything related to COVID-related research, we made them freely available so that other researchers could build upon them, other researchers could experience what we already know, and then use that to build for the future. So again, this is something that is very, very important to you. If you just go to IEEE.org and type COVID-19 IEEE resources, it'll come up with the latest. And this is something that is a dynamic page, so it is constantly changing. And I'd strongly encourage you to take a look at that. Now, having talked about the resources, I want to pivot and speak about 2 particular areas of IEEE, which I believe are critical to engineering the future. The first one of them is education, and then I'll talk about humanitarian activities. And finally, as I said, I'll come back to my university and talk about 2 examples, one from the field of renewable energy, another one from the field of assistive technology engineering, that really hold signposts for the future and how we can come up with this sustained future. So thinking about education, I think about this flywheel. So as a volunteer, many of you are familiar with technical activities, publications, MGA, IEEE USA, the major boards, standards, educational activities, and so forth. But really what it is when we all work together and that flywheel starts spinning really fast, it happens because of collaboration. So the goal of education across IEEE is to expand our collective impact through collaboration. And collaboration takes all of these spokes on that hub working together to envision programs to increase the value to our members, right? So where can you find the resources? If there's one thing that you want to write down from my talk, please write down that website, ea.ieee.org, right? That is the one-stop shop where you can find details on all of educational activities. There's opportunities for you to give feedback. If you're in the Bangalore section, if you're in a chapter, technical chapter, you have resources on education. We also publish an online newsletter, EA Insight, as well as opportunities for partnership programs that I'll speak about in a minute, right? So thinking about educational activities, I sort of put this landscape under 3 boxes: pre-university education, university education, continuing education. The one in the middle, consider that as the foundation. These are programs that we've been doing for a long time. You heard in the introduction that I'm the new president-elect for ABET. ABET is a global accrediting body for engineering education, computing, applied and natural sciences, and technology. I represented IEEE on ABET for over a decade, and I'm very, very honored and humbled to now be the president-elect of ABET, having been elected by all of my peer societies. IEEE is the largest society with an ABET, which constitutes about 25% of ABET's programs. Eta Kappa Nu, our honor society, EPICS and IEEE. During the pandemic, we created what's known as a Teaching Excellence Hub in partnership with the IEEE Education Society. This particularly provides resources for educators. Think about a very simple activity that our students do in all of our engineering disciplines. They have lectures and then they go to labs. They do hands-on practical activities. How do you deliver hands-on laboratories in this virtual environment? And the answer is absolutely you can, thanks to the technologies developed by IEEE. So that is sort of the foundation that we have in the middle. These are things that we've done before, we'll continue to do, we'll continue to improve. On the left and the right, you see the bookends, the pre-university programs and the continuing education programs. Yesterday, if those of you who attended the inaugural ceremony for Connect, you heard President Kathy Land speak to you. And Kathy has been a huge champion of diversity and inclusion and promoting our pre-university education. I'm very grateful to President Land, and I'm very grateful to President-elect Ray Liu, who are both coming in, wanting to ensure that our future is secure by ensuring that we put resources into pre-university education. So we'll talk about Tri-Engineering and how that can pave the way for the future. And then looking at the future, we've just barely scratched the surface with the IEEE Learning Network, the IEEE e-learning library. All of these are accessible to you, again, ea.ieee.org, right? So we have a community of practice. I know a number of you perhaps are members of Collaboratech. As a matter of fact, you don't have to be an IEEE member to be a member of Collaboratech, but I'd strongly suggest you do, so you can take advantages of all the resources coming from IEEE. So if you're a member of Collaboratech, there is a community of practice for educational activities. Again, it's an opportunity for you to share. It's an opportunity for you to learn from others and expand your network and get it inspired. So go today to Collaboratech, join the community, hear what is being said, and find out how you can become a better person as a result of that. Continuing in professional education. Now in this space, we're looking at IEEE members and working professionals who've already got their degrees, but at the same time, they want to advance. They want to get additional experience. They want to get additional expertise as they go forward, right? What do we offer? Continuing professional education, online courses, a whole range of solutions. Right now, we have course programs, everything from blockchain, AI, 5G networks, etc., English for technical professionals. We're continuing to develop new programs, again, in partnership with our professional and technical societies. IEEE Learning Network. I told you that I'm really proud of this, and this is something that happened as a result of collaboration across IEEE. It's a shared learning management system, and it's been built to improve the learner experience with continuing education from over, that number is actually outdated, 30 different partners. So if you're looking for a webinar, if you're looking for a course, you can take courses from all of these societies through the IEEE Learning Network. If you see something here that should be featured, contact your section, contact your region director, contact your technical society president, and make sure that IEEE pays attention to that and puts it into the IEEE Learning Network. Our goal should be to broadly disseminate this so that all members can benefit and engineer the future. And premiering soon, this is something that President Toshio Fukuda initiated, the IEEE Academy. So IEEE Academy, again, looks at it from the perspective of the end user, smart grid, artificial intelligence, and Internet of Things. And in case you're wondering how we came up with these topics, we actually surveyed about 4,000 members of the IEEE who are all in industry. And out of that survey emerged these topics saying this is what we need to do in order to make a difference. On the pre-university side, our new and improved STEM portal launched in January of 2021. We have a STEM grant that we launched in May of 2021. We've actually received about 60 applications as of July 1. These are small grants to enable sections, groups across the IEEE to do activities in the pre-university space between now and the 1st of December to have an immediate impact on pre-university education. Tri-Engineering Tuesday, again, an opportunity to work with technical societies, number of different societies that talk about different topics related to our future. Lesson plans and translation. This is great because of diversity. We have translated lesson plans into a number of different languages. You look there, Urdu, Hindi, etc., Telugu. So there's lots and lots of opportunities for you in your local sections to connect with your members and serve them. Now let's talk about humanitarian activities. When you think about humanitarian activities, I think about entrepreneurship. And the United Nations Sustainable Development Goals that you see in front of you, something that I know all of you are familiar with, is where IEEE entrepreneurship and humanitarian activities meet. After all, advancing technology for humanity requires us to come together from many different disciplines to address these challenges. So the mission is to foster entrepreneurial engineering and technological innovation for the benefit of humanity. Now, this again, it's not an affinity group, IEEE Entrepreneurship, but anybody can join it. You don't even have to be a member of IEEE to join it. They have speakers, they have panels, they have entrepreneurship stars, numerous different events connecting numerous different affinity groups, but bringing together the power of IEEE to make a difference in their local communities. So please check this out. Last but not the least, EPICS and IEEE, Engineering Projects and Community Service. 3 years ago now, in 2018, the last time I visited India, to sign an MOU with my alma mater at NIT Trichy, we were looking at service learning. How do we engage university students to do projects in their community, right? And we want these projects to be sustainable long-term. So we have 4 themes: access and abilities, education and outreach, environment, and human services. And the beauty of these projects is that they not only involve university students, but they also involve pre-university students. So what happens to the students is that they get better technical background, problem-solving skills, teamwork, communication, everything that you read in the Engineer of 2020, and the community benefits as a result of this. And then finally, looking ahead for 2021, we're building on this development, right? We're looking at an immediate need. So if somebody says, I need to have an app to find out the spread of COVID-19 and how we can limit it, we have a team of students who can work together to create it. So EPICS and IEEE, it's a fantastic program that has done this. And here's what I'm really proud about. If you look at the middle box right here, 36% of the university students who participated in EPICS and IEEE are women, and 42% of the pre-university students have been women. Extremely important for the IEEE. Our women in engineering is the fastest growing group within the IEEE, and programs like EPICS, programs like IEEE Entrepreneurship, programs like ILN, we need to strengthen diversity and inclusion using these programs. Now, I want to pivot to the last part of my talk, which is to give you 2 examples, 2 very quick examples from my own experience as an educator here in the California State University system. So my university, just to give you a perspective, has about 40,000 students. It's the largest campus within the CSU system, about 5,000 faculty and staff. And if you think about 45,000 people in a complex which has about 400 acres, we consume a lot of energy. And so we have a lot of renewable technologies, the technologies that I'm showing you right there. We have fuel cells, we have microturbines, both static solar cells, as well as what we call concentrated photovoltaics, which we did in conjunction with Spectralab, which is a subsidiary of Boeing. So these panels that you see here have a dual axis tracker, so they actually track the sun, and they can produce renewable energy, and we work on storage. At the time we installed our fuel cell, we were the first university in the world back in 2007 to have a 1.2 megawatt fuel cell. All of this contributes almost 20% of energy to our campus. But interestingly, our students said, we can't just stop at that. We have to figure out a way to reduce wastage, to reduce pollution, because our fuel cell, the feedstock is gas, and how do we reduce CO2 emissions? So what the students ended up doing is creating a rainforest, a sustainable rainforest. We had about 1/3 of an acre. They created a sustainable rainforest to sequester the carbon that comes out from the fuel cell plant. So I'm going to play a brief video about that, and I hope my technology cooperates here. So here we go. I don't know if you're hearing the audio, but if not, I would have to.
No, audio is not there.
Very good. So let's pause on that because I was afraid of that. I needed to share the audio, but in any event, the fuel cell that we have and the sustainable rainforest actually sequesters the carbon emissions, right, that is being created by this fuel cell. I can send you the link later so you can look at it in the interest of time. So the other thing that I wanted to share with you is the area of assistive technology engineering. So you ask, what is assistive technology engineering? So assistive technology engineering is an area where you bring life scientists and engineers together to work on technologies, prosthetics, and devices to make a difference for people who are physically challenged, cognitively challenged. This particular project that we created is a project to build a brain control interface for a wheelchair user. So the person that you see right here in the wheelchair, Lee Hearn, he actually has 2 degrees from our program, master's in computer science and a bachelor's in mechanical engineering. And he's also a patient and a subject in the research. The idea is, can this person navigate a wheelchair using their thoughts for cognition and using their thoughts for movement, right? Sounds like science fiction, but we were actually able to do that. And I know you don't have the audio, but you can actually see the video right here. I'm going to go ahead and play the video. But before I do that, you can see how the technologies have come together. We used a headset to monitor EEG waveforms. We used a neural network to put it together. And without any latency in real time, it takes the thoughts from the user, translates that to a motion command. And yes, we have fail-safe technologies. There's cameras, there's GPS, there's a laser rangefinder from Northrop Grumman, because we want to ensure that there are no fatalities or there are no issues with this person actually using the wheelchair. So I want to show you a brief video. Again, there won't be any audio, but just take a look at the video as you see it right here. So this is Lee, and Lee is moving forward in this wheelchair. Basically, the wheelchair is sensing the commands through his thoughts. So what has gone into the design of this intelligent wheelchair is lots of image processing, lots of signal processing, power electronics, hardware, software coming together, and all of this being done with 0 latency. Imagine this, right? He just thinks that he wants to move forward, and it takes his thoughts, translates that to a motion command, and then the wheelchair begins to move forward. Isn't that amazing, right? This is the envisioned future that we're talking about. AI, IoT, data, all of this coming together to make a difference. Now, this person can move the wheelchair simply by thinking that they want to move forward, right? So that is, again, a really, really wonderful thing for us to do. Now, we didn't stop with this. We said, what can we do further? How can we make this even better? So we actually created a master's degree program in assistive technology engineering. And you say, what is a master's degree program in assistive technology engineering? Well, here it is. So the program brings together biology, biomaterials, design, software engineering, project management, all of this together. And here's the good news. It is completely available online. And we did this even before COVID-19. So that's a website. You can take a look at it. The next cohort is going to be starting in the spring. You can start in 2 years. You can become an assistive technology engineer. So where do these people work? We have companies like Boston Scientific, neuromodulation. We have companies like Medtronic MiniMed that creates insulin pumps for people with diabetes. All of these aspects, I think, are happening as a result of collaboration, as a result of the work that we do in the IEEE. So again, we won't play the video, but there's a brief 2-minute video that you can check out online. I can send the links to the organizers later so you can see that. So putting it all together, engineering the future. As you've heard from me, when you think about the future, communication is important. Teamwork is important. Interdisciplinary research are important. We need individuals who can think across systems. We need to be thinking about sustainability. And more importantly, we need to be thinking about cultures. How can we address the global challenges, but locally and locally with impact? And the new realities of global innovation. Travel is still not very possible across international borders. So there's increasing distance between people who innovate and their markets. And what we need are engineers who can compete, but also collaborate globally. And I think it's absolutely important that we pay attention to inclusion, diversity, and equity, because that is the way we engineer the future. So as I get to the very end of my talk, collaboration is critical to our success. Lots and lots of examples there. Virtual conferences, IEEE education, learning network, pre-university education, etc. But I thought a picture is worth 1,000 words. A few years ago, I was in an IEEE meeting when this group of young professionals was there at the meeting. And during a break, one of them said pyramid, right? And in about 5 seconds, they formed a human pyramid. There was a base, and you see Sarang Sheikh is actually a volunteer from Pakistan who was on top of that pyramid. How did that happen? How did that happen? How did that collaboration happen? There was teamwork, there was communication, and people knew. They knew that in order to form the pyramid, you need to have a base, you need to have a strong foundation, you need to communicate, you need to collaborate. Ladies and gentlemen, there is no shortcut to this. There's an old African proverb, if you want to go fast, go alone. But if you want to go far, go together. We need to work together to engineer the future in the post-COVID era. So I will end where I started. Where are we headed? We are headed to an era where innovation through adversity is going to be the mantra, the definition of resilience. And if there is one thing that you can take away from this talk today, I would ask you, do you want to make a difference in the world? Do you want to make a difference in the world? And I think the answer, unabashedly, unapologetically, unequivocally, would be absolutely yes. And I would say, I captured that with one phrase, I care. And you say, yes, Ramesh, we care. What does that mean? I care as in, let's be inclusive, let's be collaborative, let's be accountable, let's be resilient, and let's be ethical. Let's make a difference in the world. Let's engineer the future together. And let us hope that Connect 2022 will be in person in Bangalore. And I hope to be addressing you in person a year from now today. Ladies and gentlemen, thank you very much. Here is my contact information. Feel free to reach out to me if you have any questions about my presentation. And I'll send you the links to the videos that, I'm sorry we couldn't play those today, but I certainly hope that you get a chance to see them. I will stop sharing at this point and turn it over back to our organizer. Thank you.
Thank you, sir. We have time for probably one question. Any panelist can ask one question.
Yeah, since there is no question from others, I would like to ask one question on the assistive technology, whatever the wheelchair augmentation was done. So is it only thought or is the gesture also in that particular thing?
So thank you, Dr. Bindumadua. So we use gestures also as a supportive mechanism. So you can use eye gaze, for example. In some instances, people can use audio commands. But we were looking at somebody fundamentally who's cognitively sharp, right? Who had their mind, but for some reason, let's say a person with a spinal cord injury, right? Who does not have the ability to move, but cognitively they're very sharp and they can think. So the beauty of this, Dr. Bindumadua, is that headset that I told you about, that's the same headset that video gamers use. So at the time we used it, that was about $250. It was from a startup at Stanford called Emotive. And the students took it one step further. You know, at a fundamental level, it has two commands, right? It's you can go forward, you can stop, you can turn right or turn left, right? And they said, fine, we can use that. And they trained with that. They created an artificial neural network in the background. And they said, how can we relate the EEG waveforms? The neurologist that we worked with, initially he was very skeptical. He said, what do you mean monitoring thoughts? How can you do this in real time? And I'll tell you the biggest surprise. I was giving this talk in Austria a few years ago at the conference on helping people with special abilities. And somebody asked me, Dr. Ramesh, can we take those thoughts and convert them back, you know, into a command? And I said, hold on just a second. You know, you're asking us to play God, okay? We are barely scratching the surface here. We're trying very hard to help somebody. So there's a lot more to learn. But your point is absolutely well taken. The laser rangefinder itself was about $250,000, and it was donated by Northrop Grumman from their inertial guidance division. And the students took it one step further. They started saying, how can we make these more affordable, less expensive, and commercialize it so that more users can use it? And then what about places where, what if you don't have a pavement, right? How do you use a wheelchair in an environment that there's not? So all kinds of opportunities. But short answer to your question is absolutely. It uses gaze, it uses audio. You can use any number of technologies because it's very hard. I've tried myself as a professor. You know, most professors don't read the manual. So I tried myself. I can go forward, I can stop. I can't turn right or turn left because I didn't practice.
So maybe I'll ask one question. With more and more programs going online, so online education is the mode of the day. So what is the future of this physical education? The nature people used to get educated, will this drastically change, or the physical universities still have a lot of importance in near future?
So that's a great question. And, you know, I'm not answering this from the perspective of an academic who sits in a physical university, because my university is going to transition to face-to-face in the fall with 50% capacity, provided people are vaccinated. There's a lot of ifs, right? Provided and so forth. And I would say that this was something that needed to happen to higher education. Okay. I'm not saying that people getting sick is a good thing. I'm saying that we needed this disruption. Higher education needed to be jolted. Okay. I think previous speaker talked about whack-a-mole, right? He said, if a mole shows up, you whack it and it shows up some. Higher education needed to be knocked on the head and said, wake up. It's time that you start using technologies to envision the future. So absolutely, I think we need to be looking at hybrid. We need to be looking at virtual. There is a space for people to get together. There is a space, I think, for people to come together as a community. My own programs that I run, I know the students are very eager to meet face to face because they believe that will lead to collaboration. But think about all the things that we have developed as a result of the last 15 months, right? None of this could have happened without the technology. So I envision a very bright future. I envision that some things should and will change because nothing should be static. And this is exactly the kind of impetus that higher education needed going forward.
So thank you very much, sir. That's all we have time for today. So thank you very much for the wonderful talk and your thoughts. A small token of appreciation, virtual memento from the IEEE Bangalore session.
Thank you so much.
Thank you, sir. Thank you.
Thank you, everybody. I wish you all a great evening and a great cultural program. Thank you.
Thank you.
Thank you.
So with that, we come to the end of the plenary session. So now we will move on to the cultural events. There will be a lot of entertainment from our student volunteers. So over to Dr. Sujata, so who will coordinate this.
Thank you, sir. Namaste, everybody. This is Professor Sujata, Chair of Student Activity Committee of IEEE Bangalore section. Today, Rashi Srivatsa, one of our student volunteers, will be managing the whole session. So this is the event by the students for the students. I welcome you all for this wonderful cultural extravaganza. Over to Rashi to kindly start the event.
Thank you so much, ma'am. Am I audible?
Yes, Rashi, you are.
Yes, ma'am. Thank you so much. A very warm evening to one and all present here. I'm Rashi Srivastava, and I would like to thank you all for joining us today. So, Mahatma Gandhi once said that a nation's culture resides in the hearts and in the soul of its people. How true it is, not only diverse in its technical tracks, IEEE Bangalore section's 7th edition of its flagship event, Connect, aims to celebrate the cultural diversity as well. In this vibrant and very happening cultural night of Connect 2021, we can sit back and put our thinking caps to rest and sail through the smoothness of this event. It is an honor to welcome everyone present here on this divine evening. I would like to welcome you all to join the night with amazing performances lined up for today. So before we get started with the celebration, let us pause and think for a moment. Let's ponder upon the past year. Let's ponder upon the hardships and the mental pressure that our frontline warriors had to go through. Let us pay our small token of respect, appreciation, and gratitude to our frontline workers through this short movie by the students of UVCE Bangalore. I would request Prithvi to put up the video now. Thank you so much. I guess there is a little lag from our side. The video will be put up in a moment. Sorry for the inconvenience caused.
Sometimes we have challenges with technology. Our rehearsals went on well. I hope to see the video. With a lot of efforts, the kids have made a small video. Sorry for the inconveniences. We are actually trying from the backup.
Mom, I'll just try sharing this screen. Because I don't know if there's an issue with the audio.
Hopefully it will come. Please.
Okay, just a minute. I think we're gonna share in case we don't optimize it for video. Just a minute. Is it audible?
No, audio is not there.
Okay. Just look into that. Just
Try increasing the volume.
yes, ma'am, the volume is maximum. I think it's because of WebEx that we're unable to share the screen with you. Just a minute, ma'am. All right, I think I should be able to share the file now. Prithvi, could you just state presenter access? Shambhava sir? Okay, it's visible.
such a heart-touching video it was. I truly salute all our frontline workers for their unparalleled dedication and being the heroes in the needed time. So maybe now is the time that we dive in the cultural extravaganza that we have planned for you. And to set you grooving and get your feet tapping, we now have an Indo-Western dance mashup by Gautami from Vidya Vikas Institute of Technology, Mysuru. I would request Prithvi to put up that video. Thank you, Prithvi. What an amazing performance it was. I surely had myself enjoying. And I hope you all did too. I wish I could really hear those thundering applause from all of you. But anyway, since we are in this difficult time, so maybe I'll just ask Gautami to come over video call once and maybe we can recognize her. So here we have Gautami. Gautami, could you just introduce yourself a bit?
Audio is not there, Gautami.
Gautami, your voice is breaking a bit.
Your voice is breaking.
It's okay, maybe there is some bandwidth issues. So maybe we'll move on to our next performance now. So here we have a one of its kind, rare, but always a delight. So I'll call upon Deepak Shashank from BMSCE for his surprise performance. Over to you, Deepak.
Am I audible? Hello.
Yes, Deepak, you're audible.
Yeah. Good evening to one and all present here. It's been a delight to hear all the speakers, and good evening to all the panelists as well. I am Deepak, and I'll be the performing artist, and I perform beatboxing. To those who don't know what beatboxing is, it is an art of mimicking percussion instruments and sounds that you may hear daily, which may be uncanny, you know. So, for example, let me take my set of instruments. Do you see any instruments here with me? No? Perhaps not. Okay. So, for example, I can mimic a drum set machine, right? So, this is a kick drum. This is an hi-hat. And I have my snares. When I combine it, it makes music. So, something like this. Converted to hip hop. You know, something there's strange. So I take a sip of my water elemental beatboxing water. I don't know. So I can do something like water drops. And there are like a lot of uncanny sounds that beatboxers can produce. For examples, whoever has watched the movie Three Idiots, amazing film, one of the popular films in India. He said Zip is also like a very good, incredible machine, right? Zip. So let's take, I have an imaginary zip right over here. So I pull it up. You can add it in music. Now that becomes a beat, zip beat. So anything is actually anything, any sound the world produces is a music actually. You think that actually humans are very incredible, right? You can make music from anything. Let's say, for example, we all snore at night. Don't pretend you all don't snore. We all snore. So yeah, you add that in a beat. So a snore would sound like generally very awkward, right? When you're snoring. It's like you're snorting like a pig. So you add that in music, it becomes music, right? So yeah, you know, we have wonderful throats which can produce harmonies, basses. One of which I like is called a throat bass, which was popularized later because of transformers, robotics, the sounds which we produce. For example, if I was to pretend I was a robot, I would be like, yo, 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 my name is Deepak. So now I would put that in the Transformers dialogue, which would be like, yo, 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 this is Decepticons roller. And from that, we create the music called dubstep, which would sound like this. Wow, 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 wow. Wow, 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 wow. Wow, 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 wow. And congratulations, now you can call yourself an a cappella artist. I'll tell you why now. So let's take for example, you can even recreate your own remix version of a song. We all know the great singing artist Charlie Puth. I like his songs. I took example, one of his songs were Attention. So now I would try to remake it using beatboxing, which would be like, you just want attention, you don't want my heart. Maybe you just hit me with someone new. Or for example, we could also remix the famous Hindi song, I Am a Disco Dancer, which is a very famous song. Something like this. I am a disco dancer. I am a disco. So those are like some of the examples I could give while you can, recreate your versions of music. So there are a lot of interesting stuffs you can do with beatboxing. For example, again, hip hop culture was invented. Then, there are some musics which you thought you couldn't recreate using your human mouth. One of the type of music I like is comes from the sound of South, right? The local tapang of South India. So it would sound like this. So it also helped me like come through wheezing. Like even my wheezing could be added in a beat right now. So let's say I would regularly like do sounds like this while I was wheezing. Now I could produce that and make it to a trap beat. How? So let's try this out. Trap music. Thank you guys. I hope you guys enjoyed the music I created. And the last thing which I would like to end with is since we are missing clubbing a lot because it's the pandemic, right? Because let's finish this off with a virtual club music. So let's pretend that you guys are outside the club, right? So this is how the club music would sound outside the club. If you're so you're going to enter the club. This is how it's going to sound, the transition. Now everybody bounce. Thank you guys. Have an excellent evening.
Thank you so much, Deepak. Like, oh my God, how do you guys do it? I'll never know. But now that I've got up with some beats, I'm sure you all did too. So thank you so much, Deepak, for this lovely and delightful performance. So we have got a music, we have got a dance, and to complete this set of performance, next we have a monologue performance by Sanket Raj Patil from UVCE. Sanket, do we have you here?
Yes, of course. Hello, hello, Alpha to Delta. Alpha to Delta, do you copy? Hello. This is a message from base 13, Regiment 64, do you copy? I'm sorry I have to whisper because the enemy is just around. They'll catch my signals. The enemies have crossed the line. Extra shellings have destroyed all our camps. We have completely lost. I'm injured. I've lost an eye. Completely helpless. Delta. Delta, do you copy? Delta. Over and out. Delta, this might be my last message. Probably my last recording for a long time. All my brothers and the regiments are dead. If the enemy didn't kill them, survival surely did. The war's going on since 3.5 days now. Food and water ran out yesterday. There's no way anyone's making. There's no way anyone's making out of this. Oh God. Oh God. This is driving me insane. This is driving me insane. I don't even know. I don't even know who I am anymore. I'm so weak. I'm so alone. It's so tough out there. I don't know what I'm gonna do. I don't know what I'm gonna do. Yes. This was a volunteer badge which my teacher gave me back in the village. Somehow, somehow she always knew what to do. Somehow she was always brave. And somehow, until now, I never realized what an absolutely brilliant volunteer she was. She fought her way through every battle of life. The day I signed up for this war as a volunteer from the local villages, she was so proud of me. She was so happy. That's the day she really told me what a true volunteer means. That's the day. A volunteer is not about what can be gained, but is always about what can be given. A volunteer is not about only how he can change himself, but it also includes how he can change the world around him. A volunteer is not about helping himself, but rather helping the world around him. Are you really a volunteer if you don't walk with your comrades? Lift up your comrade when they're down and help your fellow volunteers. Are you really a volunteer? Wait a minute. Wait a minute. It's it's all coming back. I know what she said. She said, when anyone and everyone give up, that's when a volunteer decides to outshine his own strength, his own bravery, perseverance, and more importantly, the spirit of volunteerism. You know what she said? I remember. And a group of people who did this together has become the greatest volunteers of the world. That's right. That's right. I know who I am. I know I am a volunteer. And when I signed up for this, I didn't say I would quit. I didn't say I would give up either. I didn't say I would give up either. I've lost an eye. I've lost an eye, but I've lost not my brain, legs, or my life. I'll walk this path. I'll walk this path alone if I have to. I won't give up until my last breath. I'll go out there. I'll go out there with my gun. I'll show them all what my teacher taught me. I'll show them all what a true volunteer is. I'll show them all what a difference a true volunteer can make. I'll show them all. I'll fight. I'll fight through the night with every might. Jai Hind Delta. Jai Hind. Over and out.
Truly a stellar performance. That was amazing, Sanket. Truly an amazing performance. Now, adding on to Sanket's performance, well, can we guess what's that one thing that connects us all in this meeting? What's that one thing that binds us all together? Volunteerism? IEEE? Perhaps foremost in this meeting is both. Let's just take a glance at various benefits you can reach from the IEEE membership through this video. I would now request Risha to play the IEEE benefits video to us. Hello, Risha, do we have you here? So that, my friend, was IEEE benefits video. And this is how IEEE benefits us all as professionals. Well, ladies and gentlemen, hold yourselves back for an amazing amalgamation of music now. So let us present to you Swara Saurabha by Pallavi Pai, Sanjana and Vaishnavi from Canara College of Engineering, Bangalore. What an amazing performance it was. I can really hear someone clapping. So that's the feel maybe. Well, we are enjoying virtually. So can I invite all the three girls here on video so that they can have a quick introduction to themselves and people here can recognize them? I see Pallavi here.
Yeah, so sorry, the other two members could not join because of network issue.
That's really fine. Your performance was wonderful.
Thank you so much.
Amazing. So moving on next, is there anyone who cannot be charmed by music? Well, to charm our ears and to bind us all to our culture, I invite Audrey Govius from Canara Engineering College, Bangalore. Audrey, do we have you here? Well, I see Audrey here. Audrey, maybe you can unmute yourself and...
Yes, I'm here.
We cannot really see you, Audrey. Is there some... Oh, okay, you're here.
You see me now?
Yes, perfect.
Okay. So, good evening to everyone, to all the panelists and all the attendees here. My name is Audrey Govius. I'm from Canada.
Audrey, there's
a couple of
your
songs
voice
here,
is
so
breaking up.
I hope you enjoy it. Can you hear me?
Yeah, but there was a little breakage in your voice earlier.
Okay. I hope I'm audible now.
Yeah, you are perfectly audible now. Please go ahead.
You've got a friend in me. You've got a friend in me. You got troubles. I got two. There isn't anything we wouldn't do. We stick together, we see it through, 'cause you got a friend in me. Some of the folks might be a little bit smarter than I am, bigger and stronger too, but none of them will ever love you the way I do. It's me and you. And as the years go by, our friendship will never die. You're gonna see it's your destiny. You got a friend in me. You got a friend in me. You got a friend in me. Here's another one. मैं गुम हूँ इन राहों की तरह, तेरे ख्वाबों में, तेरी ख्वाहिशों में छुपा, ना जाने क्यों है रोज का सिलसिला, तो रूह की है दास्तां, तेरे ज़ुल्फ़ों की नमी, तेरी आँखों का ये नशा, यहाँ को भी जाऊं तो मैं, क्या कसूर है मेरा। क्यों है अफसाने इन लम्हों में खो गए, हम कायल थे इन लफ्जों में खो गए थे हम अनजाने। अब दिल में तुम हो छुपी, हम हैं शहर की परछाइयाँ, तेरे सांसों की रात है, तेरी होठों की ये सुबह। यहाँ को भी जाऊं तो मैं, कसूर है मेरा। तेरी जुल्फों की ये नमी, तेरी आंखों का ये नशा। यहाँ को भी जाऊं तो मैं, क्या कसूर है मेरा, क्या कसूर है मेरा, क्या कसूर है मेरा। Thank you, everyone.
Such an amazing voice you have, Audrey. No wonder all of us have already fallen for such an amazing voice. That was wonderful performance. Thank you so much, Audrey. So, cherry on the cake, or maybe Sone Pe Suhaga is what we call it in Hindi. So, call it whatever. But on top of all, we have an exciting Jugalbandi performance to show you all. Risha, I would request you to put up the video, please. What an amazing performance it was. Absolutely wonderful. May I request all these students from BMSC to show up here? That was
Just a
really
minute.
an amazing performance, guys.
Yeah, Rashi, continue. Sorry.
Hello all, can you hear me? Hello?
Now you're audible. You weren't earlier.
Yeah.
Okay.
Yeah, so that was really an amazing performance, all of you. So I can see one student from BMSC here, Aditi. That was really an amazing performance, Aditi. Absolutely wonderful. So with this, we wind up here today for cultural performance. But here we'd like to announce another great news with all of you, that IEEE Bangalore section is proud to present IEEE Region 10 Humanitarian Technology Conference, that is Art in HTC. This year, the theme for IEEE Art in HTC is Reverse Innovation Technology. Reverse innovation for humanitarian technology solutions using STEM, science, technology, engineering, and management. The conference will be held in Bangalore from September 30th to October 2nd, 2021. Can we have the video, please? Thank you so much for the video, Risha. So maybe before we call it a day, can we have all of you on video so that we can have a quick group photograph? I would request all of you to turn on your cameras for a quick photograph. I guess we have taken a few photographs. So maybe, hello. So now I would like to request the chair of IEEE Bangalore section for closing remarks. Over to you, sir.
So it's almost 9:22. So from the morning, we have been having the combination of technical as well as the cultural event. So I would like to thank especially the student activity chair and the student members who performed the cultural program. It was really a good thing after a heavy dose of technical inputs. So this was trying to sort of give us a relaxed feeling. So I thank one and all who performed today. Thank you. So we'll see you all tomorrow.
Sir, Professor Ramesh is there with us for long, so can we hear from you, sir?
Absolutely. I want to congratulate all of the students, everybody who performed. It was truly heartwarming to see your creative talents on display. I wish you all the best. In fact, I kept thinking about my remarks on engineering the future, and you truly embody that future. So Dr. Bindu Madhava, Dr. Kumar, Professor Muralidhara, to all the students for your outstanding performance. Be brave, be bold. We know that the future is yours, and I'm delighted to be a part of it. Thank you.
Thank you, Professor Ramesh, for being here for such a long time. Thank you. Yeah. Lakant, you want to announce something? Tomorrow's?
No. So I want to thank Professor Ramesh and another panelists and Professor Muralidhara for conducting the nice session, and overall the students who performed so nicely. Actually, I was glued to the screen for complete this one. Though we are all there from since morning 9 o'clock, but still we are having that energy that again we will start tomorrow morning again, so fresh. So all the student volunteers, it's all credits is due to you, and you are the force that is driving this conference. So I hope it will grow in future editions more and more. So with this remarks, I conclude. Sir, you may kindly.
Yeah. Good night and stay safe. See you all tomorrow. Thank you.
Yeah.
Thank you all.
Thank you, sir.
Everybody, thank you, Dr. Kumar. Bye-bye.